Assalamualaikum. My name is Nurhaliza Shazwani binti Muhammad Halim and my metric number is B09181027. Okay, I'm going to present about my project, which is to develop a monitoring vibration system using Raspberry Pi. The objectives of this project is first to design a monitoring system using a Raspberry Pi. Second is to establish a connection between user and microcontroller through network system. That is where the VNC apply on. Third objective is to analyze a proper technique to sense a vibration using a breadboard and calibration frequency sensor and amplifier to gain in the prototype. The first focus of the work is to design a signal condition where a Raspberry Pi can interface with the vibration input. Second is to actually develop a monitoring vibration mechanism using the selected sensor, which is the piezoelectric sensor, to obtain a vibration input. Third is to develop a prototype into an IoT with a suitable programmable, which I choose for this project is Python, which to design each function in this project. Fourth is to establish the connection with the power supply, test for the vibration sensing. Lastly is to analyze the accuracy of vibration, consumption, reading, and gains. The hardware component that used for this project is first Raspberry Pi 4 Model B. This is known as a credit-sized chip that fits into your monitor computer with a user standard like a keyboard and mouse. It is also capable to create your own program. The second component is piezoelectric sensor. Actually capable of converting physical parameters such as acceleration, strain, or pressure into electrical charge, which can be measured by external component, which I use ADS115 module to convert my raw input into digital input. This goes to the third hard component which I mentioned just now, the ADS1115 ADC module. The most two important hardware component before proceeding any step of configuration the Raspberry Pi is to have the micro SD card and power supplies. The power supply is needed to power up the Raspberry Pi, which allow to test any program are installed correctly or not. The micro SD card actually to store the Raspberry Pi operating system. In this video, I will show you how to make a Raspberry configuration. First of all, you need to switch on your Raspberry Pi and let it reboot for a few minutes. password here are not visible. Next is the methodology for vibration sensing distribution. Based on the diagram that I provide in the slide, the system shows vibration sensor detect a vibration and takes the raw input directly to the ADC before converting to Raspberry Pi. This is because the purpose of ADC is to convert the raw value into the digital value. So based from this project, I converted the raw value into voltage. So when the input converts into digital, which allows the Raspberry Pi to read and display it on the display Raspberry windows that shows in the diagram. The last methodology is a flowchart for the overall system. Based from the image that I provide in the slide, shows there is no and yes testing. From what I observed from this project is, without the software development, connection of the hardware and the IoT will not happen. This is because the software development is which allow us to make a configuration into the software that improve uses of the device. Second, when the software development is successful, proceeding to the hardware development. Each device has their own coding program. This is where the VNC plays its part, where we can read and write the coding to test the functionality of the hardware component. When both software and hardware is functional, the third step is to develop a connectivity with both development, having the hardware to use the software for wireless monitoring system. In this video, I will show you how successful this development of monitoring system using Raspberry Pi. The next is result and discussion. Result, which is the first is the relative sensitivity of the sensor and the concept of using the monitoring vibration sensor, and a secure privacy, which this device does not share any photo and videos. The second result for this project is the vibration sensing. From the image that I provided in the slide, if two of the example vibration that I took from the testing, altogether there is a 30 tests of sampling data, and based on the image you can see that the piezo sensor able to receive and positive and negative input from the vibration. The second result for this project is the vibration sensing. From the image that I provided in the slide, if two of the example vibration that I took from the testing, altogether there is a 30 tests of sampling data, and based on the image you can see that the piezo sensor able to receive an positive and negative input from the vibration. Lastly, to obtain the prototype efficiency, RMS is used to find the accurate value. Multiple of testing are required, which result that the data that obtained is very reliable for the operating system to monitor. Conclusion for this project is that the monitoring vibration system went successful with Raspberry Pi, but with the basic knowledge, coding are required for the application. However, the result is very satisfying as the value is within range, which is the R squared equals to 1. My recommendation for this project is to use higher sensitive sensor that could help to improve the reading of an analog signal. Second, that we could adjust the set range of minimum and maximum value for the operating system to measure. This is end of my slide. I hope you understand and thank you for your time.